Hello everyone, I'm Level 36 and welcome back to Stationeers. We're back on Mars! I have been doing some in-between session thinking, planning, prep, mining, all that stuff. So I have continued setting up our silo setup. So I'm pretty sure what we were working on last time. It has been a hot minute since I've actually played on this world. So we have these silos here. We set them all up so that they feed into this main bus. And the idea being that we want to be able to request ore from the silo and then send it either to our furnace or our arc furnace or our main furnace. So ideally, the end vision, the goal here, is to have this set up so that from our furnace room we can just say, I need to request the stuff for a steel ingot, or for a 200 steel ingot, because everything's stored in quantities of 50. It'll just go, okay, do, and send it all over here. That's the goal. We'll see how far we can get with that goal. So I did do some off-camera scripting. I have put together some IC10 scripts, probably way too complex for us to use. I also printed up all of the IC10s we'll need, some chutes and some other stuff that we're going to need to do this project. Doing okay on power for now. We are kind of at the limit of what our power system can provide. And also we're out of water. So real quick, let's just go fill up our main water vessel and get our plants growing again, because we kind of need more potatoes. Have you. Depressurize. Into the elevator we go. I think after we set up this silo control system, I'm going to actually seal up the base and finally start pressurizing everything. What do I have in here right now? Tracker. Okay. Crap. Let me go grab the Atmos analyzer. Anyway, I would like to say thank you all for watching, everyone. I do hope you are enjoying this series, because I'm certainly enjoying making it. I saw some news. It looks like the next version of Stationeers that is coming out is going to have a lot of new mechanics. Or not necessarily new mechanics, but the whole terrain system is getting revamped, which is pretty cool. So I'm excited to see. Let's turn this down a little bit. I don't think we need it to be as extreme, because we don't want to blow up our water tank here. But this has a pretty decent size capacity, so I don't think we need to be too worried. Fill this up with water. Good enough. Disconnect you, switch you back. Drain this pipe. There we go. No liquid, no liquid, no liquid. And now we can grab our filled up water bottle and take this back upstairs. I have to print up some more pipes so we can just plumb this in directly, but we'll get to it when we get to it. I'm not going to actually auto-cycle this because I don't want to launch this canister. We'll let it actually pressurize itself. And now we can grab a drink and plant some fresh potatoes. Nuke that one. So yeah, the script system that I wrote up is probably far more complex than necessary, and I'm probably overthinking this. But I kind of wanted to do it without getting much guidance from anywhere else, because I wanted to see what I could come up with. So I have come up with something. It is probably not a final version, but I'll also post the code below. One of the reasons I haven't really been... I used existent scripts for the furnace, and I got some feedback on this, so I want to do it myself in future, is because I don't like posting the script text that other people have written in my YouTube comments or in the description, but I will post anything I write. So all of the stuff I wrote for this will be down in the description below. But essentially the system consists of 2 main parts and 1 supplement. And like I said, this is by no, I even know this isn't the most efficient way of doing this. There's definitely, I could reduce the number of required ICs by at least half. But essentially the way it works is I wanted it to be somewhat generic, because at some point I may store things other than just ore. So each silo gets an IC. I'll go grab those. That IC essentially watches a controller IC for the hash of the item stored in the silo. If it sees that hash, it dispenses one of the items in its inventory out, and then the system kind of resets and it does that again. Now, theoretically, this system, so the way that controller works is any hashes that are written to its stack, so the internal device stack, anything that's written to its stack will get processed. So you can write as many values to its stack as it can hold, which is a lot. But ideally, like right when we're doing things with super alloys, theoretically, we could say, hey, we need nickel, cobalt, silver, silver, and it would go dispensing nickel, cobalt, silver, silver, and then that would get sent off to the furnace. But I don't want to send out partial stacks. So what we are going to build as well is a little catch so that it gets, hey, we've gotten so many things through. I'm expecting to have 4 stacks. The system has dispensed 4 stacks successfully, send it out. Or I'm expecting to get 4 stacks. We've only dispensed 2 stacks successfully. Or if there's any unsuccessful stack is actually what it looks for. The system is unable to dispense something unsuccessfully, send it back to storage. We're not going to actually complete this request, and then we'll tell it, hey, the request failed. So all of that being said, we'll see how this works. So let me grab my bits and bobs, and we're going to get this set up. Put away some stuff that I don't need. Power sheet's good. So IC housings. Did I make too many IC housings? I might have made too many IC housings. Oh well, I'm sure we'll use them elsewhere. So we need IC housings. We probably need some more cable actually. So I'll have this make some more cable. Coils, please make me... Also, I think I may have figured out why these are starting... These fail sometimes and how to prevent it in future. So... hopefully I can fix that in a future episode. We're going to need... Also, I want to set this up initially because I'm not going to set up the whole like intelligent request system. I want to set it up so that I can select, hey, I just want some of this, essentially. From, well, you know what, why not set up the whole intelligent request system? Maybe. We'll see how far we get. Let's start with the basics. IC housings and cable coils. So IC housings, we're going to stick one of these behind each silo. Also, I did very minimal testing of this. So this is kind of one of those cases where in theory it should all work. But we'll see how well theory holds to practice. Okay. And I will probably post a separate video detailing exactly how these scripts work, or maybe it's not warranting of exactly a separate video. I'll walk through them real quick when we're setting up the first couple of devices, or if we have to make any changes to them. Also, I wanted some more LCDs, because I do want to display how much is in each silo, which is going to also require some more cabling. We'll figure that out in a minute. I'm going to run out of cable anyway. Oh, and we needed one more IC housing. Because we are going to need the kind of controller IC, which we'll put... do I want to put it out here? Just tuck it back to, or to put it on the side over here. We'll tuck it in the back. Or no, the side. Want it to be right here, in fact. Alright, now we just need to go grab a bunch of circuits, or actually we can set up the chutes. So what I was kind of talking about with the buffer is we're going to create a little like loop in the buffer in the chute system with a valve that will hold back everything that is being dispensed until we're sure we have everything, and then it will send it all through once we know we have everything. So let me grab some chutes. Just hover for a second. We'll use window shoots just so we can see what's going on. Then we can grab our powered shoots, because that should be plenty. We want a shoot digital valve. Then we'll actually need some more shoots. I can place the other one. And then we're going to also want a shoot flip-flop sorter. Put this right there. There's our fresh cable. Good, and that's some powered shoots, that's some regular shoots, that'll be good. Let's actually grab some more. We might need some more shoots. Put these in. Hope doing a little bit of extra planning reduces the amount of faffing around that I have to do to get all of this to work. While I do enjoy showing everyone the process of me figuring things out, sometimes when I'm working on really complex systems like this, it's a lot more convenient to just be able to build it than to have to, like, narrate what I'm doing while I'm trying to build it. So this is the return, essentially. Kind of to what I was saying. But hopefully it's not like, oh, you should have shown your whole process, because it was like 4 hours of me trying to figure out how to make this all work. Which wasn't particularly fun. It was a lot of me going, let's try this. Maybe. I did do it in this world. I guess maybe I should have made a copy of the world or made a like testing world, but I figured it was okay. I might do that in the future, though, if I'm going to be building something complex again, is do it in a separate testing world. So I'm not incrementing the day counter, because we are significantly further, well, only a few days further into the game than we were. I tend to pause the game when I'm actually writing the scripts, so that saved us some energy. Where did my laptop go? Alright. So now we need to start moving ICs over. So I should be able to put the chutes back. 1, 2, 3. As well, so we can grab all of our me just see which one we are looking at. So this is iron here. So toss my laptop down, grab that, put that in there, edit this. We're going to clear that, go to the library, and grab our silo control script. So I'll walk through how this works real quick. We have a control. The control alias is the master control IC. The silo, the one we're actually controlling, an LCD. This is if we want to display the quantity inside the silo. And a status, which is set to itself. So this is a couple to define. The item hash, this is the hash of the item we're storing in the silo. And this should be, for this one, iron. I think this is defaults to iron right now. Then storage quantity, which is the quantity of the items in our storage system. We initialize some stuff. We set our own setting to 0, so the status is set to 0, and we set the silo, turn it on. Then we wait for request. So we load from the controller the setting. We branch if it is equal to the item hash. We go to this dispense function. Else we just set the LCD to branch. So we branch device not set. So this kind of tests to see if the device exists. It's a piece of optional device handling. So like theoretically this will work before I set up all the LCDs. That's just how we load the LCD up, and then we yield, and then we go back to WaitForRequest. So if I confirm this, export that, grab that, stick that in there, we're going to need to name some things too. So these all need to be named. The name is important here. Silo control. Because on our main system, we're using a load batch name command. Okay. So this one is in there. Let's now configure it. So we're going to set this to IC housing, and the second device, I'll turn it on real quick. Second device needs to be set to SBD silo iron, and then there's no LCD is optional, so we don't need to set that for now. But it hasn't done anything, so theoretically it's working. And we'll just kind of keep going down the list. Up my devices real quick. I miss it. There we go. Nope. Things seem to be in different orders. Okay. This is copper, so we're going to set this one to copper, gold, this one's lead, nickel, silver, cobalt, oops, coal, and this is none of them. I think this one's supposed to be silicon. There we go. All right, now we just need to set up some ICs. Stick you in there, go to here. We're going to just switch out this item hatch for each one. So next up should be copper. Grab that. Export. Then we need gold. That. And we need lead. So what I mean by I know I could at least cut this by half is if so I'm only using 3 of the device registers. I could also use the other 3 device registers. So I could control 2 silos per IC. And then if I really wanted to be super efficient, theoretically, it's a little bit more computationally expensive for the game. I could use set batch name to write to the silos from 1 IC. But that seems unnecessary at the current moment. What is my next ore type? Nickel. Cool. My idea with leaving them like they are right now, though, is that I may want to change... I keep forgetting to check the next ore type. Silver. Change some things, add a couple extra devices, so I figured I would do it 1 for each now. And then, if it becomes necessary in the future. Are we running out of power? Game just bugged. Uh-oh. And through 2,000 watts. Yeah, I think we were running the network a little short on power. Cobalt. Coal, and then silicon. Let's just write those last 2. Well, yeah, we'll just be careful. Coal. You are going in my hand. And then silicon. You're going in my inventory. Yeah, I guess I forgot to like finish my thought, but what I was going to say about the upcoming updates to Stationeers is it looks like it's a complete rework of the terrain system for the game, which is going to be pretty neat. Ore spawn, it's moving away from procedurally generated terrain, which I like the procedurally generated terrain that we use right now. I understand why there might be some desire to get rid of it a little bit, but like, I don't know. I fully agree. So this is what I guess I was trying to think about real quick. Since I want to be able to write to this one's stack from the main network, because I need to be able to communicate. I don't want to run like a separate communications bus I need to expose this to the main power network's logical I/O port. So I'm, oh, we might have to think about that. Might be some problem solving in here after all. We'll see what we can do, because I know there's a logic mirror where you can communicate between two networks. We'll have to see how that works. But we'll walk through this script real quick. See all of the various silo control scripts. Actually, I don't even need that on right now. So for this one, we're going to clear library. We're going to get the main controller. So this one, we define the control hash as silo control. So that's the name of the device that we are referencing. We have our self valve is D0, outflow is D1, loop count is register 11. Got some initialization stuff. We clear our own stack. We set the valve to on. We close it. We set its quantity to 0. We set the outflow to on. We set its setting to 0, setting output to 0, basically making it so it won't switch directions just based on how many things go through it. Then we set its mode to 1, which is the bypass mode, which is going to send it back into this network. Our main loop. We get points to a position on a device's stack. So we're getting into our 1 from our own stack position 0. So the way that the init or the OR request script works is it's going to write the number of things it's writing to the stack. So 1, or it's going to write the minimum of 2, which is 1 item. So the indices and the item. And then if like we were requesting 4, it would request 5. So it would set the 0th position, so the first position in computers, to 5, which would tell this system, because we're going to move into stack pointer that return value. We're going to say, hey, get the 10th. So we're going to move up the stack.
Hydration critical.
X number of positions. So 1, 2, 3, 4. And then when we go and get the things, so then we go to the set request, we pop the first value off the stack, which gets the value from the stack pointer, SP, which is a special register, -1th value. And then we move stack point. We also decrement stack pointer as well. So one of the things that's slightly confusing about MIPS is it's important to remember that pop. So say you have your stack pointer set to 4. Pop will return the 3rd value from your stack. So you need to return the stack pointer value above what you are actually trying to get, which is why we write like 5. But yeah, and then we move this into 10. I don't remember if I do anything with that anywhere, actually. I don't think I do. That was a kind of remnant of some testing stuff that we do. So we branch not 0. So if our 0 is equal to anything besides 0, we set request. It should always return 0 if nothing's been requested of it, so the stack is empty. If it's empty, we just yield and jump back to main. If it's not empty, we then go to set request, we yield to start. This seemed to help a couple bugs. We close our valve, we pop R1, so we pop the first, I'm going to say the first value, the topmost value off the stack, because we set our stack pointer to the indices above the topmost value. We grab the topmost value from the stack, we branch if equal stack pointer 0. So if the stack pointer is now equal to 0, we're just going to go to request complete. That means everything's done because the stack is empty. We set if it's not empty, we set the self setting to R1. So this is what all of those devices, so all of the silo controls are watching, the self setting. So once this setting goes to a item hash, we yield, then we initialize loop count to 0. We load batch name into R10, this value, which is the IC10 controller's bloody prefab hash ID, the control hash, which is the name, the setting, and we sum these. So only one should be responding at a time. If it responds 1, that means this request was successful. If it responds -1, that means the request failed. If it doesn't respond either, we go to loop count, we set loop count equal to, or we add 1 to loop count. If this reaches 5, which means it's looped through 5 times and nothing's responded, we go to request failed. So basically, if something responds, we go to failed. If nothing responds, we go to failed as well. The jump yield and jump return just goes back 6 lines. So 1, 2, 3, 4, 5, 6. So we just kind of loop that 5 times. And then if it succeeds, though, so hey, something's dispensed, we go to set request, which just comes back up here and starts from the beginning again. Pop the value. So if we only have one thing, once it gets this once, it'll go back up, pop, this will be equal to 0, we go down to request complete. Request complete, we set our setting back to 0, saying we're not requesting anything anymore. Might actually be a good thing to note that we may need to mess with this a little bit. We'll see how this works. I'm just thinking of a couple things. We set our setting to 0. We set the outflow mode of the, or the mode of the outflow valve to 1. We set the outflow switch to 0, which is the straight through mode. We set the valve to open. Then we clear our own stack, and then we jump back to main. If we fail, we set our setting to -1, which kind of is our... I'm using -1 as the something went wrong value of the setting. We clear our stack, we yield, we close, we set our setting back to 0, the outflow mode to 1, which means we're returning it back into the inventory, and then we open the valve, and we jump back to main. Hopefully that makes some degree of sense. Let's export it, throw it in here, configure it, and we'll go drink some water. Turn this on. This needs to be the valve. This needs to be the chute outflow. And it is now running. Nothing has happened, because nothing is supposed to have happened. We should have some stuff in at least like a couple of these. Or not. Let's go grab some water so I don't dehydrate myself to death. Realize I've just spent 40 minutes basically explaining how those things work and setting up those couple of things. I really hope they actually work now. So I guess with what I was getting at is right now this is all on this logic system, so it's isolated. So to be able to write to this stack, we need to be able to pass that through. So logic mirror doesn't say what it does. I think it's only one data connection, which might be a problem. So we might have to figure this out. So I want to be able to basically send a communication signal down this kind of main high voltage line, so we're not having to run a whole bunch of cables around. Guess we could... For now, I know this is a for now solution, and I try not to do those. For now, we're going to put all of this on the same circuit, and if we need to change it later, we will do so. But I want to see how if this actually works the way I think it's going to. Then I'm going to do a whole bunch of mining, get some more things to put in the systems so that we can hopefully test some more. So we are going to want a display to see what we are requesting. Which way is the top of these things? This should work. Okay, we're gonna need a dial and a button, and then our IC housing. We'll put somewhere. Let's put it over here for now. We got plenty of wire. This one hopefully will be a little bit more simple. Grab our ore selector and send that through. This is a fairly simple script. We have our self, dial, button, and request manager. That is the IC, that is the request system. A library of hashes. So, hey, this is a whole bunch of hashes. And I guess I could also implement D3. We'll see if we need this in the future. I'm not going to actually go through and implement it right now. But we kind of just set up our dial. So we set the dial editing setting to mode 8, the dial setting to 0. Then so this kind of just sets up that dial, and then in the main loop, we loop through. So we load the dial setting into R0, we add 1, because if the dial is at 0, the system doesn't really work, because we have to do a jump relative down here. So we're always going to have a minimum value of 1. We set our setting to R0. This was a debug value that we don't need to do anymore. We multiply the value by 2. So if it's 0, or if the setting is 0, it's 1, becomes 1. 1 times 2 is 2. Again, another debug value that we don't need anymore. We jump relative by whatever this outcome is. So say it's 2. So we go this 1 2. We set our self setting to coal. So the hash of coal. Then we jump to the next label, and that's the same for any of these. So if it was, say, the setting was 4, so this would be 8. So we go 1 2 3 4 5 6 7 8. We're gonna get the gold value. basically just a big switch or case statement. The next, we load whether the button has been activated, and if it has, we add the request. If it has not, we just jump back to main. So this add request section is we are just loading our setting into R2. We are writing to the request manager. So this is when we're writing to that stack that I was talking about. In the 0th position, we're putting 2, which is so if we're thinking about the stack here, right? Like let's say 60 is the start of our stack memory. So this would be position 0. This would be position 1. So 0, we're going to write 2. And then in 61, so this is position 1, this request manager 1, R2, we're going to write the hash. And then what the other one does is it looks at position 2. If position 2 is not 0, it's going to set the stack pointer to this value. So 62, and then when we pop the first time, so we pop the first value from the stack, it's going to get the next value from the stack. So that would be 61, and then it does it again, and it says, oh, we're at the 0th position now. Now we're complete. So that's what that does. We're putting 2, and then we put the hash in the first position, we yield, and we return to main. Confirm that, export that, take that, stick that in there, turn that on. I'm going to have to configure this real quick. This should be the dial. This should be the button. This should be the request manager, which is going to be... I should really rename this. IC housing, silo control. This one, IC housing or request. This one needs to be IC housing silo control. Logic mirror is unset, which is fine. Should be fine at least. So now, in theory, also that didn't turn on. Odd. Well, let's see if theory to practice works. We need that's a sorter motherboard. Whoops. Grabbed the wrong things. Hash display. That is the one we need, and a sheet of glass. Also going to need my data disk, I'm realizing. Data disk, where art thou? Jeez, where did I lose my data disk? I need that. There it is. Okay. Whew. Thing's slippery if you don't keep track of it. We want to set this to request. Alright, so right now we have a request in for coal. If we push the button, this should be back to 0 because nothing happened. Now though, if we set this request to There we go. I think I have to just reinitialize these. There we go. Set that to 1, which is iron. We have at least one thing in there. Push the button. 1 iron gets dispensed. It gets dumped out the bottom. We have requested 1 iron. Hooray. It appears to have worked. At least part of it has. Oops. Wrong direction. Stick that in there. Let's grab a whole bunch more chutes and actually send this down into the basement where it's supposed to go. Feeling I have some more around somewhere. Yep. Really should just mine out a whole area over here. Put away our data disk because we're going to need to drill out some more material. And my drill is right there. That is where it comes up from. So if we kind of tunnel through real quick. Make some room. Oh, off. Let's just make this. For now, we're going to have it just kind of thread the needle through the rest of the stuff. You can still walk underneath that. That's fine. Organization. We don't need organization. We embrace the spaghetti here. Okay, so now... Now that we've maximized the amount of spaghetti that's going on over here, any request we get, also if we... Well, that's it. Let's go back to coal real quick. Let's push the request through. Oh, it failed. It went back. So now let's go grab a whole bunch of stuff and fill up some other things to make sure anything else works. Should be able to just do this by grabbing a mining belt. Thank you. Open this. And just grab a whole bunch of the ore that we have in this locker over here, which will also be very nice because it will free up this locker. Make sure we're grabbing 50 stacks, because even though it will work with less than 50, it's just going to get stuck in the sorter, which we don't necessarily want. We even grab another mining belt and grab the rest of the stuff. Doop, 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 doop. No! Be a proper stress test of the whole thing. Finally freeing up that space though. We also need to add our little input thing up there so we can just dump things from upstairs instead of having to come down. Dump you in there, dump you in there, dump you in there, you in there. Cores are processing through the network. Pretty quick, actually. Mining belts back up there. And out here, let's see. 1 in there, 0 in there, 0 in there, 7 in there. You are our lead silo. 4 in there in the nickel silo. Nothing in there. Cobalt silo. Coal silo, we've got 8. So I'm interested to see what happens if we request coal now. So I want to make sure it only dispenses 1. Sounded like it worked. It did indeed work. Okay. Jeez. I think that was pretty cool. I think it worked. I want to try 1 extra bit of something now. I'm gonna need another... I had another IC housing, right? Processor. I know I have enough logic switches because I printed a bloody million of those. Stacker. Stick sheet, logic switch, logic I/O. Are you the one that can do the logic mirror? Yeah. My thought here is that this should enable me nothing is set, but in theory, now if we go through here, oh, oop, that was the wrong one. Silent control, there we go. Logic mirror, if we set this to the Is the logic mirror not a settable device? I need to set it to, like, read something first? I wonder if it will actually just mirror the whole device. Looks like it does. Station battery. Let's just see if station battery shows up now. Wait, there it was. Logic mirror. But it mirrors the whole device, which means, in theory, I wonder. Grab some water, because my guy needs it. And then we will test something. Need to print up another logic I/O kit, perhaps. Forgot where I put my water for a second there. Got some more potato, yeah. If I was to move this logic mirror now, reinstall it in the opposite direction, that's a logic reader, not a logic mirror. And this is our silo control. I wonder if we can write back through it. We just need another IC and IC housing. Test if this is going to work. I have sworn I had an extra IC housing sitting around somewhere, but I guess I don't. D10. Need 1. Is make. I'm excited if this works. Actually, I should go retrieve my laptop as well, because I don't want that to get annihilated in a dust storm. But if this works, especially indoors, that'd be pretty freaking cool. So then I can just... I think it'll have to be downstairs for now, that's fine. So ultimately... Well, I'd like to have it... Ultimately, at that point, it doesn't matter. We can wire it in wherever we want. Are we out of something? Maybe you just need iron? Not iron, but steel. Do we not have any steel? Remember I said I think I know how to fix this? Let's just do that real quick. See if I can remember how this bloody script works. And the button is pushed. First thing we're going to do in assemble is clear the tabs stack. That should, in theory, is still locked. We have view set to 0. Nope, didn't fix it. We write it? This is the right script. We're stuck in a different state. We're in this state here. What in the bloody hell did I do? I think this script is all kinds of screwy. The needed hash. Needed hash to fab hash. Okay. Then we jump to request. I'm gonna probably rewrite this, honestly, at some point. But it's doing that. It sleeps for 5. Then it jumps to end request, or this is end request, which is where it looks for. Why did I do this way? This is awful. I don't know. We're just gonna slap that back in there. Hold the button down a whole bunch of times. It should, in theory, reset it eventually. Forgot I had to set that back to. Just have to catch it at its 5-second timeout. Yeah, that's not. I gotta redo that script eventually. That's not the way that's supposed to work. We're out of steel. Which should be easy enough. to make some more. If I could ever remember the recipe, 3:1, iron to coal. So we only need 1 coal. We know where to get that from. Coal, 1 of you. Then we should be able to grab, let's set this to 50 because we don't want to dispense a bunch of crap we don't need. Iron, 50 grams. 1, 2, 3. One ball of coal. This system on. Definitely tell which scripts are the ones I've written, which scripts ones are professionally written. Toss in our coal, iron, 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 activate. There we go. Thank you. Now we should be able to, in theory, make the thing that we need, which is an IC10. One of you, please. Yeah, let's go down to the downstairs. Where is our main power line? It's over here. Need some more. No, we can just do it right here. It's just for testing. I'm gonna probably set this up a lot better eventually. Logic switch. And we've got some heavy cable coils already. D10, and then we're gonna need an IC housing. One, you please. Button. Dial. Oh, I'm out of bloody copper. And I don't have any more. It's my mining drill. Let's just grab like 1 copper from somewhere random. Some right outside the base here. We don't go down one of our various little holes into the earth, we should find it. I just want to get this one project done. I'm not trying to do a bulk mining episode. I'm definitely always prepared for making these episodes. I don't know what anyone means. We should be able to flash our IC10 at least. Library, this is going to be the ore selector. Overwrite. Okay. Confirm. Export. Did I send that in the wrong spot? Or is my auto smelting thing just not working today? Oh, it's just off. What? Why is it off? Why is it locked? What? There's a bunch of stuff that's stuck in here. Okay, whatever. We're just gonna fix all that later. Where did that copper go? Maybe you need power for that to work. Do the iron as well while we're here. Should really just use this furnace for everything. Just decommission this stupid little thing. It's a power hog anyway. It's easy enough to get atmospheric gases for making fuel for that. That should now work. There we go. That was hard enough. I don't understand what happened to this stupid thing that it got mega borked. But it appears to have gotten mega borked. We are actually just going to put those there. And alright. We have our IC housing. I left my laptop upstairs. Let's see if this works. Screwdriver. Boop. Boop. Style. Button. Logic mirror. The moment of truth. This should request 1 coal. And it failed. Memory not writable error. Okay. That's all I really wanted to see, is what would happen. I kind of figured it wouldn't work. So, ooh, I need a new filter. And it's a... Come back here! Come back here! Bloody dust storm. Oh, my laptop got dented. That's sad. Well, no better time to wrap things. Why is it a dust storm in here, too? Or is it not? Is it just a visual bug? Nothing's getting damaged. Yeah, I think it was just a visual bug. We'll close those just in case. But yes. Some changes will need to be made. I kind of figured that might be the case. We couldn't write through the logic mirror, which it does turn out we can't write through the logic mirror, which is not terribly surprising. So we'll have to change that up, but I'll probably get to that. Yeah, I'll get to that next time. I want to finish this project. I have so many unfinished projects. Finish this one. From this one, we will go on to the next one. And the next one, and the next one, and the next one, and so on and so forth. Okay. With that, I hope you've enjoyed seeing me flail around and try and get this set up. As much as I'd love to show it through the big window, I can't right now, but we did get our silos somewhat automated. We can now request specific things from a silo, and it will get dispensed to us. So next time, we will automate this a little bit further. Might change up some of the scripts that are running over there as well. But yeah, we'll automate this a little bit further and get the ores delivered automatically to our furnace. I think I am going to do just the main furnace and not faff with the little arc furnace. We'll have to figure out what in even the world happened to that poor thing at some point. So, I thank you all for watching. I hope you've enjoyed. If you have, please be sure to drop a like, a subscribe, or a comment to let me know what I've done wrong and how I have horribly messed this whole system up. Don't worry, I wouldn't be surprised if I have. So, I do appreciate your time watching, and I hope to see you all next time. Thank you all, and have a wonderful rest of your day.